Hello, my name is Todd Olson, and I will be your statistics teacher this semester. I wanted to shoot this little video to introduce myself and to talk a little bit about my philosophy about this course and how I teach this course. Um, First of all, I'm sitting here in my office. I teach at College of the Redwoods in Humboldt County, California, near Eureka, California. And I've been teaching here since the mid-90s, and I actually started teaching before that at Humboldt State University. And one of the early courses that I taught, I should also mention I do have a master's degree in applied mathematics, and I have a BA in pure mathematics. And I've actually taken quite a few stats courses, and I've taught stats for quite some time as well. But I started teaching statistics at HSU, a course called Nursing Statistics. And then I got the job here at CR and started teaching elementary statistics here way back in the 90s as well. And my philosophy about this course has really changed over the years. And part of what I think motivated that change was a realization that what students really need from this course is the ability to think critically about data and about likelihoods and about a decision-making philosophy, really. Um, and so, to kind of, I want to share a little story with you. I was at a party a few weeks ago. My wife's a lecturer at Humboldt State University, and we were at a little get-together for one of her colleagues. And I met this gentleman who's a linguist, and we were talking about math and how math's like a language. And he shared with me that he took a statistics course when he was in graduate school. And he said that to him the course seemed more like a course in R. And R is a statistical programming language. It's a fairly sophisticated piece of technology. I don't know exactly what to call it. I guess I would call it a statistical package. And I told him what I told him was I thought that was a shame, and I do, because he really missed out on, I think, something that's really more important than the technology, which is really the philosophy and the critical thinking part of it. Now, I have to say, you have to crunch numbers to do statistics. I mean, that's just the reality. And we do need technology when we teach statistics, that's for sure. But my point of view and philosophy on technology is I want to do as much as I can to keep the technology from getting in the way of learning the philosophy behind statistics. So I've opted to use this calculator as our technology, and this is a rather amazing calculator, really. It's a TI-84, the one I'm holding, and the other version of this calculator that's perfectly fine for this class is the TI-83. The TI-83 is an earlier generation of this calculator. Now, this calculator will do all the statistical number crunching that we need for this course. I like the calculator because it's light. You can put it in your pocket, carry it around. It is an amazing, you can program it. I'm going to actually show you some programs. I think the next video I'm going to do is going to involve how do you program this calculator, but I'll save that for later. And it's relatively inexpensive. Many of you already have it because it's actually required for our intermediate algebra course. So if you took that course here, you probably already have one. In any case, we're going to spend a lot of time with this. I'm not going to kid you. This calculator is going to take up a lot of our energy and time, but it is going to do all the number crunching, and it's going to do some amazing number crunching that hopefully I'll be able to shed some light on and give you a little bit of a glimpse of what's going on mathematically as well with this machine. But really the main focus of the course is going to be more conceptual, more like a philosophy course or a critical thinking course. And the way I teach statistics now, and specifically the way I assess what students understand about statistics involves more writing. I'm going to actually ask you to write some essays for this course. And, I've been doing this for a while, and it's been a good experience. I think the students that I've helped with their essays and the ones the essays that I've read over the years have been some amazing pieces of work. And they really show that the students that have done that well have showed me that they can do more than just crunch numbers, that they actually have a conceptual understanding. Because what I've discovered is that really what you're going to be asked to do if you do statistics after this course is very likely to write about it, to be able to explain what something like a p-value means. You're going to learn about p-values in this class, what type 1 and type 2 error rates mean, and the confidence level for a confidence interval and all of those things. You're going to have to be able to explain what those mean. And so that's going to be a big focus. And I think a good way to learn and begin to understand and make concrete in your mind what those things mean is to write about them. So there'll be writing assignments. 2 major essay exams, I call them essay exams. The first one's really an essay. The second one will involve a data set and some number crunching, and then some critical thinking and interpretation of what the particular values that we end up getting mean. But both of those assignments are actually collaborative efforts. I strongly encourage my students to work together. In fact, when I teach this course face-to-face, I do a number of activities in groups. And I like my students to try to get to know each other, because one of the things that I discovered as a student was it was really useful to work with other students, to help them and ask them for help. And especially when it comes to writing, I've done a little bit of consulting work in statistics. I've written a couple of, or I co-authored a couple of papers, and those are collaborative efforts. Definitely, we all work together on the writing component, and so I like to model that kind of thing in my class. And so I'm actually going to ask you to, and require you to, communicate with each other through email. And one of the things we're going to do on the first essay exam, for example, is I'm going to ask you to share your essay with a couple of other students from the class, and I'll arrange these groups and everything ahead of time, so you'll be able to. I'll give you their email addresses and make it easy for you to contact them. But I want to attempt to simulate that kind of group experience in this online course, and one of the ways I hope to accomplish that is by using what are called pure response groups in the writing world. And the idea is that you'll write your essay, your rough draft, and you'll email it to a couple of people from the class. And I have actually these fairly brief forms that I ask you to fill out, critiquing their writing in a very specific way. And if you really take that seriously and help your colleagues or your peers by giving them valuable information instead of just cursory kinds of stuff, but actually really spend a little bit of time and think about what they're trying to say and help guide them, I think it'll help your writing as well. And certainly the advice from your peers can help too. So that's one of the things we're going to be doing. That's probably not what you would expect. The other thing that I like to do in this class are things called simulations. And one of the really important ideas in statistics is this thing called the frequentist interpretation. And it's a really kind of a subtle thing. And this frequentist idea really, it affects some of the language that we use, in fact. For example, we call our prediction intervals, we call them confidence intervals rather than probability intervals, which is sort of a subtle kind of a language thing, but it's important, and it's actually, there's a reason why that has to be. And, and that's related to this frequency idea that we'll talk about, and I'll try to develop very carefully in class so you can hopefully understand it. But so that's going to be kind of a different approach. So my course, I hope, won't seem like a course about technology, even though we're going to use technology. We have to. Um, I really want you to see the course more as a blend. I'd like to think of this course as um, um, a course in philosophy, like I said, and critical thinking, and at the end, a course about mathematics. And I want to take just a minute to share my feelings about that as well. I started out as a pure math major, and one of my favorite classes to teach is calculus. And really a lot of the mathematics behind statistics is calculus based, and fascinating. But the interesting thing to me, or one of the interesting things to me, is that pure mathematics is in some senses a hypothetical kind of a world. Um, Sometimes these mathematical ideas apply to the real world with mind-boggling, um, you know, uh, congruencies, and it's truly amazing. But then you have to ask the question, how do we know how well these models really fit the world? In other words, and this is kind of the thing about statistics that I find interesting. I think I really understood the abstractness of pure mathematics better as I taught statistics and realized that these things we call models, which are mathematical functions, they're called probability density functions, and they're functions, and they're mathematical functions, and they're abstract, and in some ways they're hypothetical. And you know do they fit the real world? We don't actually ever, or often we just really don't know. And we take it on faith. We make an assumption and we say, this set of numbers that we're calling the population, which brings me to another whole fascinating idea, which is, this is an infinite, uncountable set as the domain of the function. Of course, these are words that I'm sure you heard when you took intermediate algebra, but the domain of these functions is profoundly interesting because they're, in many cases, uncountably infinite. And we call that idea continuity. And so they're continuous functions. So you have to ask yourselves, when you're doing statistics, do we really have any populations that fit that domain? And of course, the argument is the domain fits quite well because the populations we study are very, very large generally, and so the assumption is probably a good one. But I think it helped me to see the abstractness of mathematics from a different angle. It's kind of looking down through the abstraction into the statistical applied world rather than looking at it, as I'm flesh and blood living in this physical world, and I'm thinking about abstract mathematics. So I think it's interesting in some ways to think about statistics as this kind of like other point of view where we're taking these really sophisticated abstract mathematical ideas and imposing them into a context. Now, I want to mention another thing as well, as long as I'm talking about this, and that is the book that I've asked you to read. And the book, of course, there's a textbook, Interactive Statistics, but you'll notice also when you review the syllabus that there is a recommended reading, and it's a book, the title is The Lady Tasting Tea, and it's a narrative history of statistics. And I strongly encourage everybody to read that book. And read it during the 10-week period for this course. Oh, excuse me. And the reason for that is because I think that book puts the whole course into a historical context that's really interesting and useful. And the other thing is I give you extra credit for reading it. So that's always a plus. And I'll give you more details about that later when I go through my syllabus and things like that on a future video. But in any case, I'm really looking forward to teaching in this course this semester. I hope it'll be a good experience for you.